Okay, I'm going to do a slight twist to the previous code that we just wrote. So let's go ahead and take whatever we had just written for that, it was called the D4 starter. Let's duplicate that. And I'm going to say about instead of min cut edges, we'll do min weighted cut edges. Okay. So the difference in this code that we're about to write, and maybe I should call this D5. Let's call it D5. Okay. The change that we're going to make now is that instead of just counting whether or not an edge is cut between counties, we're going to capture and try to minimize the distance or the perimeter of these districts. So this will be actually a very small change to the code, but may produce districting plans that look quite different. So the only change that we'll have to make to the code is instead of each time those y variables appear in the objective function, their coefficient currently is just a 1 because we're just counting whether or not the edge is cut. But now we're going to capture that perimeter, that shared perimeter between two adjacent counties. So let's see. So I need to go back up to where I define the objective. So here I just sum all of the y variables, which now I'll do the same thing. I'll sum all of the y variables, but I'm going to multiply this variable by that shared perimeter length. So I'll do g.edges, and then I'm looking at, let's say, edge UV. So this is corresponding to the border between county U and county V. And in our data set, we have the length of that boundary between those two counties. And it's stored in this field called shared perimeter, perim. So all we have to do is to add this. And now we'll minimize weighted cut edges. Maybe more specifically, we're minimizing the district perimeter lengths. Okay. So I think the code here, everything else should work as is. Let's see. I think I don't need to bother with this. Sorry. Okay. If this optimization we don't need. So also at the end of last video, we added these root fixing constraints because Oklahoma County, Tulsa County, and Comanche County have to be in separate districts. And it's convenient for the model if we just tell Gurobi that Oklahoma County should be the district root for the District 0, Tulsa County is the root of District 1, Comanche County is the root of District 2, and then we'll let Gurobi fill in the rest of the details. So let's go ahead and run this code. Okay, we're getting close. Okay, so it solves pretty quickly. It only took 40 seconds. And everything looks fine. Let's see. Oh, okay. So that's quite a different looking districting plan than before. Interesting. Okay. Anyway, so that's it for this min weighted cut edges. So we're minimizing the perimeter lengths of these districts now, and not just how many of those edges are we cutting between districts. So this may be something that you choose to do for your state, for your project, particularly if your state law says anything about minimizing district perimeter length. And I know at least a couple of the states that have been selected do have something like that in their state law.